The limit theorems will be explained and illustrated with examples. Theorem number 1. The limit of c as x approaches a is equal to c. This means the limit of a constant is equal to the constant itself. C represents the constant. Example number 1. The limit of 9 as x approaches 2. 9 is a constant, so the answer is 9. Example number 2. The limit of 9 as x approaches 5. 9 is a constant, so the answer is 9. It doesn't matter whether x is approaching 2 or x is approaching 5. Example number 3. The limit of 25 as x approaches 7. 25 is a constant, so the answer is 25. Theorem number 2. The limit of x as x approaches a is equal to a. This means the limit of x is where x is approaching 2. Example number 1. The limit of x as x approaches 5. X is approaching 5, so the answer is 5. Example number 2. The limit of x as x approaches 4. X is approaching 4, so the answer is 4. Number 3 example. The limit of x as x approaches 9. X is approaching 9, so the answer is 9. You can just do it this way. Replace x by 5. The answer is 5. Replace x by 4. The answer is 4. Replace x by 9. The answer is 9. Theorem number 3. The limit of x raised to n as x approaches a is equal to a raised to n, provided n is a positive integer. This means the limit of the nth power of a function is equal to the power of the limit of the function provided n is a positive integer. Example number 1. The limit of x cubed as x approaches 2. So the limit of x is 2, and then 2 is raised to 3. So we have 2 cubed, and then 2 cubed is equal to 8. Or you can just do it this way. Replace x by 2. So we have 2 cubed, and then 2 cubed is 8. Number 2 example. The limit of x squared as x approaches 5. Replace x by 5, and then 5 squared. So 5 squared is 25. Theorem number 4. The limit of c times the f of x as x approaches a is equal to c times the limit of f of x as x approaches a. This means the limit of a constant times a function is equal to the constant times the limit of the function. For example, the limit of 7x as x approaches 5. This is equal to 7 times the limit of x as x approaches 5. But the limit of x as x approaches 5 is equal to 5, or replace x by 5. So we have 7 times 5, and 7 times 5 is 35. Second example, the limit of 9x as x approaches 3. This is equal to the constant 9 times the limit of x as x approaches 3. 9, limit of x as x approaches 3. But the limit of x as x approaches 3 is 3, or replace x by 3. And then 9 times 3. 9 times 3 is 27. Theorem number 5. The limit of the quantity f of x plus g of x as x approaches a is equal to the limit of f of x as x approaches a plus the limit of g of x as x approaches a. This means the limit of a sum is the sum of the limits. Example, the limit of the quantity 5x squared plus 3 as x approaches 4. This is an indicated sum. The theorem says the limit of this indicated sum is equal to the sum of the limits, which means it is equal to the limit of the individual terms. So the limit of this first term plus the limit of the second term. But the limit of 5x squared is equals to the constant 5 times the limit of x squared as x approaches 4, and then plus the limit of 3 as x approaches 4. Let's write that. 5 times the limit of x squared as x approaches 4 plus the limit of 3 as x approaches 4. Now, the limit of x squared is 4 squared. Replace x by 4, and then 5 times 4 squared. And then the limit of 3, since 3 is constant, is 3. So we have 5 times 4 squared plus 3. Then simplify. 4 squared is 16. So 5 times 16 plus 3. Then 5 times 16 plus 3 is equal to 83. Theorem number 6. The limit of the quantity f of x minus g of x as x approaches a is equal to the limit of f of x as x approaches a minus the limit of g of x as x approaches a. This means the limit of the difference of two functions is the difference of their limits. Example, the limit of the quantity 2x squared minus 4x as x approaches negative 3 is equal to 2 times the limit of x squared as x approaches negative 3, and then minus 4 times the limit of x as x approaches negative 3. Replace x by negative 3, and then replace x by negative 3 here. So we will have 2 times the quantity negative 3 squared minus 4 times negative 3. Negative 3 squared is 9. 9 times 2 is 18. Negative 4 times negative 3 is positive 12. So we have 18 plus 12. And 18 plus 12 is equal to 30. Theorem number 7. The limit of the quantity f of x times g of x as x approaches a is equal to the limit of f of x as x approaches a times the limit of g of x as x approaches a. This means the limit of the product of two functions is the product of their limits. Example, the limit of the quantity x plus 3 times the quantity 4x minus 1 as x approaches 2 is equal to the limit of the quantity x plus 3 as x approaches 2 times the limit of the quantity 4x minus 1 as x approaches 2. Then find the individual limits. So we have the limit of x as x approaches 2 plus the limit of 3 as x approaches 2. And then 4 times the limit of x as x approaches 2 minus the limit of 1 as x approaches 2. Now, replace x by 2. Then the limit of 3 is constant, so the limit of 3 is 3. Then 4 times the limit of x is 2. Replace x by 2. And then the limit of 1 is 1 because 1 is constant. So we have 2 plus 3. Then 4 times 2 here, then minus 1. So 4 times 2 minus 1. Simplifying, we get 5 times 7. Why 7? Because 4 times 2 is 8, minus 1 is 7. And then 5 times 7 is equal to 35. Theorem number 8. The limit of f of x divided by g of x as x approaches a is equal to the limit of f of x as x approaches a divided by the limit of g of x as x approaches a, provided that the limit of g of x as x approaches a is not equal to 0. This means the limit of the quotient of two functions is the quotient of their limits if the limit in the denominator is not 0. Example, the limit of 4x squared plus x minus 3 over 5x as x approaches 2. This is equal to the limit of the quantity 4x squared plus x minus 3 as x approaches 2 divided by the limit of 5x as x approaches 2. So, find the individual limits here. So, 4 times the limit of x squared as x approaches 2 plus the limit of x as x approaches 2 minus the limit of 3 as x approaches 2 divided by 5 times the limit of x as x approaches 2. So this is 4 times, replace x by 2. So that will become 2 square. And then replace x by 2. So 2, the limit of 3, this is constant, is 3. And then replace x by 2. So 5 times 2. So we have 15 over 10 because 4 times 4 is 16. And then 16 plus 2 is 18. 18 minus 3 is 15. 5 times 2 is 10. Then cancel. By 5 is 15 divided by 5 is 3. 10 divided by 5 is 2. So we have 3 over 2. Theorem number 9. The limit of the nth root of f of x as x approaches a is equal to the nth root of the limit of f of x as x approaches a. This means the limit of the nth root of a function is equal to the nth root of the limit of that function if the nth root of the limit is a real number. Example, the limit of the square root of x raised to the exponent of 4 plus 9 as x approaches 2 is equal to the square root of the limit of x raised to the exponent of 4 as x approaches 2 plus the limit of 9 as x approaches 2. Now, this is equal to the square root of 2 raised to the exponent of 4 plus 9. Why 2? Because we replaced the x here by 2. And 9 is a constant, so the limit of 9 is 9. And then simplify, this becomes 16 because if you multiply 2 4 times, you get 16 and then plus 9. So we have the square root of 16 plus 9. And then we have the square root of 25. And the square root of 25 is 5.